नमस्कार विद्यार्थी मित्रांनो. मागच्या लेक्चरमध्ये आपण स्केलर ट्रिपल प्रॉडक्टचे ॲप्लिकेशन्स पाहत होतो. स्केलर प्रॉडक्टचे we have solved problems which are based on scalar product. Now today we will see some more applications of scalar product to geometry, and after that we will study vector product, that is cross product of two vectors. First we will solve one problem from geometry. Prove that altitudes of a triangle are concurrent. We have solved two similar problems of this type. First was medians are concurrent, and second was angle bisectors are concurrent. All these problems we have studied in 9th standard also. Here method is changed, so you will find same problem, altitudes are concurrent, in 9th standard geometry book, and here also again we are solving this problem, but there we were using plane geometry method and here we are using vectors. So here first I will explain the diagram. In diagram, ABC is a triangle. Two altitudes are drawn. First altitude is drawn from A to side BC and its name is AD. Second altitude drawn from C, its name is CF. And here though you can see the third altitude which is drawn from B. I will not draw that altitude, but instead of that I will join B with P and produce it and show that it is altitude. Okay. So let me give the names. Suppose A bar, B bar, C bar, D bar, E bar, F bar be position vectors of these points, and let two of the altitudes, altitude AD and altitude BE, this altitude AD and altitude BE intersect in P, and suppose position vector of point P is P bar. So AP is perpendicular to BC, BP is perpendicular to AC, AP is perpendicular to BC, BP is perpendicular to AC, and because of this their dot product is 0. Their dot product is 0. AP dot BC is 0 and BP dot AC is also 0. Now this AP can be written as P bar minus A bar, position vector of second point minus position vector of the first point, dot this BC bar we read it as position vector of second point C minus position vector of first point B. And similarly we write this second equation, BP dot AC is equal to 0 as P bar minus B bar dot C bar minus A bar, and that is equal to 0. Now how to make use of these equations? We use distributive property over this, P dot C, P dot B, A dot C, A dot B, and write them in this form. We simplify this second equation, distribute and write it like this. Now these are two equations. Now we observe that in these two equations I can find this P dot C, here P dot C, here A dot B, and here also B dot A. A dot B and B dot A are same. So if I subtract second equation from first, this P dot C will get cancelled, and this A dot B will get cancelled if I subtract second equation from first, and I will get this type of expression. Now how to write this expression? Here dot is required. We take P dot common here, P bar dot B bar minus A bar, C bar dot from these two C bar dot A bar dot C. We take C bar common, so we will get minus C bar common. So we get B bar minus A bar. Here also we have B bar minus A bar. Now we take this B bar minus A bar common from these two, and we will have this C bar minus A bar in another bracket. And finally we read this C bar P bar minus C bar as CP bar dot AB bar. So see, we have proved that CP bar is perpendicular to AB bar. We have proved that CP bar, here is CP bar, CP is perpendicular to AB. That means CP produced is also altitude. And this proves that three altitudes are concurrent. Okay, so this was application of scalar product to geometry. Now let us study the vector product, which is also called as cross product. So if we have two vectors A bar and B bar, if we rotate this right-handed screw, there are two types of screw. One screw, when rotated in the direction of fingers of our right hand, and if that screw moves at once in the direction of thumb, that screw is called right-handed screw. Generally most of the screws are right-handed screw. Very rarely in practice we come across the right-handed screw. म्हणजे आपण पेनचं झाकण काढताना पहा कसं फिरवतो ते. आपण पेनचं झाकण काढताना अँटी क्लॉकवाईज डायरेक्शनने फिरवतो. When we have to open a cap of our pen, if it has thread, see in which direction we have to rotate it, move it. And if we want to open suppose lid of some box, एखाद्या डब्याचं झाकण असतं ते जर थ्रेडवाला असेल, ते जर उघडायचं असेल, त्याच पद्धतीने इफ यू वॉन्ट टू ओपन द कॅप ऑफ युअर वॉटर बॉटल, सेम डायरेक्शन, अँटी क्लॉकवाईज डायरेक्शन, वी रोटेट इट इन अँटी क्लॉकवाईज डायरेक्शन. Very rarely you will come across the situation where you have to open it, you try to open it, and instead of opening it, it becomes fit. म्हणजे आपण काढायचा प्रयत्न करतो आणि ते पक्क बसत जातं आणखी, कारण त्याची डायरेक्शनच वेगळी असते. म्हणजे उघडायचं असेल तर क्लॉकवाईज फिरवावं लागतं. अशा पद्धतीचे पण थ्रेड असतात. तुम्हाला उदाहरण सांगता येईल का? मी किती सांगू शकतो, म्हणजे 10 म्हणलं तरी उदाहरणं मी सांगेल, पण तुम्ही शोधा तुमच्या अवतीभोवती. तुम्हाला असे लेफ्ट हँडेड स्क्रू कुठं पाहायला मिळतात? लेफ्ट हँडेड स्क्रू म्हणजे नॉर्मली आपण त्याला बसवायला गेलो तर तो उघडेल आणि उघडायला गेलं तर बसेल. ऑपोजिट सेन्स ऑफ रोटेशन असतो. असे कुठं आहेत पहा. तर आपल्याला इथं राईट हँडेड स्क्रूच्या डायरेक्शनचा विचार करायचा आहे. इफ वी रोटेट अ व्हेक्टर ए बार, इफ वी रोटेट अ व्हेक्टर फ्रॉम ए बार टू बी बार, हा ए बारला ए बार पासून बी बार पर्यंत जर आपण रोटेट करायचं ठरवलं असं, आणि जर व्हेक्टरने राईट हँडेड स्क्रू, इफ वी ट्राय टू रोटेट अ राईट हँडेड स्क्रू फ्रॉम ए बार टू बी बार, then definitely that right handed screw will move in some direction. It will move in the direction of thumb, and that direction is called direction of vector product A bar plus B bar. So we have decided, just now I have told you how to decide, how to fix, how to obtain direction of vector A bar cross B bar. It is the direction in which right handed screw will move when rotated from A bar to B bar. In that direction I have a unit vector, and that unit vector is denoted by n cap. So what is n cap? N cap is unit vector in the direction in which right handed screw moves when rotated from A bar to B bar. What are A bar and B bar? A bar and B bar are any two non-zero vectors, and from A bar and B bar we have just obtained one unit vector which is perpendicular to both A bar and B bar, and whose direction is same as direction in which that right-handed screw moves. Then we move to definition. This vector product, cross product of A bar and B bar is equal to product of their magnitudes multiplied by sine ratio of angle between them, and this is a scalar quantity, and this scalar is multiplied by a vector n cap. So finally A bar cross B bar results in a vector. The magnitude of this vector is AB sine theta. Magnitude of this vector is AB sine theta. So this is definition of A bar cross B bar. So if we want to take cross product of I and J, here we have to take magnitude of I, magnitude of J, sine ratio of angle between them, and unit vector perpendicular to both. Magnitude of their magnitude of I and J is 1. Magnitude of I and J is 1. If I want to take cross product of I and J, magnitude of I and J is 1, 1. Sine ratio of angle between them. Angle between I and J is 90 degree. So sine ratio of 90 degree. 90 degrees is sine ratio 1i, and multiplied by unit vector perpendicular to both I and J, and which form right-handed triplet, that is K. 1 into 1 into 1 into K, that is equal to K. So I cross J is equal to K. I cross J is equal to simply K. Similarly, you can discuss about J cross K, K cross I cross K, J cross I. Now here in this figure I will explain one more thing. If we rotate a screw from B to A, if we rotate screw from B to A, right-handed screw, that will move in this direction. Unit vector in this direction is minus n cap, and therefore this B cross A is equal to magnitude of B into magnitude of A into sine of angle between them, same angle theta, and multiplied by unit vector. Unit vector is minus n cap. So sines of A cross B and B cross A are opposite. Sines of A cross B and B cross A are opposites of each other. A cross B आणि B cross A हे दोघांची चिन्ह एकमेकाच्या विरुद्ध आहेत. मॅग्निट्यूड दोघांचं सेम असणार आहे. दोघांचं मॅग्निट्यूड AB sin theta एवढं असेल. So two vector products A cross B and B cross A have same magnitude, but their directions are opposite. So we can say A cross B is equal to minus B cross A. A cross B is equal to minus B cross A असे आपण लिहू शकतो, म्हणू शकतो. So let us have some remarks on vector product. First remark is magnitude of A cross B is equal to AB sin theta, as magnitude of n cap is 1. N cap is unit vector. Then A cross B is perpendicular to plane of A bar and B bar. Third point is the unit vector n cap along A cross B is given by n cap is equal to A cross B divided by magnitude of A cross B. We know unit vector along A bar is given by A bar upon its magnitude. Unit vector along A cross B is given by A cross B divided by its own magnitude. So n cap can be obtained by this method. If A bar and B bar are any two coplanar but not collinear vectors, then any vector C bar in space is given by XA bar plus YB bar plus Z times A cross B, because A cross B is not coplanar with A bar and B bar, is not coplanar with A bar cross B bar, because A bar cross B bar is perpendicular to them. Okay. The next point is, if A bar, B bar, N cap form a right-handed triplet, then B bar, A bar minus N cap also form a right-handed triplet. I have explained this fact. I have also told you that A cross B is equal to minus B cross A. If A bar and B bar are non-zero vectors, A bar and B bar are non-zero vectors such that A bar is parallel to B bar, that means theta is equal to 0, then sin theta will be 0 and their vector product is 0. Converse is also true. If A bar cross B bar is 0, then either one of them is 0 vector or they are parallel to each other. So vector product of parallel vectors is 0, and if vector product of two non-zero vectors is 0, they must be parallel to each other. म्हणजे वेक्टर पॅरलल असण्याकरता त्यांचा वेक्टर प्रोडक्ट 0 असणं ही नेसेसरी आणि सफिशियंट कंडिशन आहे. जसं परपेंडिक्युलर करता डॉट प्रोडक्ट 0 असणं ही कंडिशन आपण तयार केलेली आहे, तसं पॅरलल करता कंडिशन आहे त्यांचा वेक्टर प्रोडक्ट 0 असणं. If A bar, B bar, C bar are any three vectors, then A bar cross B plus C is equal to A cross B plus A cross C. This is called distributive law, left distributive, and this second one is called right distributive. If we have a scalar m and if we want to multiply the vector product A cross B by m, we have to just multiply one of them by m, and m A bar cross n B bar can be written as m into n into A cross B. So these are some properties of vector product. Okay, some more properties are also there. How about ijk? I, j, k are unit vectors along coordinate axis. Then first property is I cross I is 0 bar because angle between them is 0. J cross j, k cross k is also 0. And I have told you that I cross j is k, j cross k is I, and k cross I is j. This diagram also helps us. I cross j is k, k cross I is j, j cross k is I. And if we go in reverse direction, that means if I take j cross I, that is minus k, I cross k, that is minus j, and so on. Now Cartesian form. This is very useful form. This is very useful. So let me read it. If A bar is equal to A1I plus A2J plus A3K, B bar is equal to B1I plus B2J plus B3K are vectors in space, then A cross B is equal to, this is A bar, Cartesian form of A bar, Cartesian form of B bar. If we make use of distributive properties and distribute them, we get a very lengthy expression. That lengthy expression can be expressed in the form of determinant, this determinant. So A cross B is given by determinant whose first row is I, J, K. In second row, we take coefficients of I, J, K from first vector A bar. They are A1, A2, A3. And in third row, we take coefficients of I, J, K from B bar. They are B1, B2, B3. Expansion of this determinant gives us A bar cross B bar. Now, we will talk about angle between A bar and B bar. We already know one formula for angle between A bar and B bar, that is cos theta is equal to A bar dot B bar upon product of their magnitudes. Now this formula gives us sine ratio of angle between them. Let theta be angle between A bar and B bar, then magnitude of A bar cross B bar. Magnitude of A bar cross B bar is AB sine theta, and therefore sine theta is equal to magnitude of A bar cross B bar divided by product of their individual, means separate magnitudes. Okay, So this is formula for angle between them. Now what is geometrical meaning of vector product? What is geometrical meaning of vector product? Means we find vector product, but what actually it is? आपण वेक्टर प्रोडक्टची किंमत काढतो, दोन वेक्टरचा वेक्टर प्रोडक्ट घेतो, पण नेमकं काय मिळतं आपल्याला, त्याच्यामुळं काय तयार होतं, कशाचे उत्तर असतं, ते जॉमेट्रिकली काय असतं ते. तर जॉमेट्रिकली आपण ए बार क्रॉस बी बार काढतो, म्हणजे एका पॅरलेलोग्रामचं आपण एरिया काढत असतो. जॉमेट्रिकली वी फाइंड indirectly we find area of a parallelogram. So here is the result. If a bar b bar are represented by directed line segments with the same initial point, then they determine a parallelogram with base magnitude of a bar and height b sin theta. In figure its height is shown b sin theta. Theta is angle between a bar and b bar. And area of the parallelogram is, we know area of parallelogram is base into height. Base is a, height is b sin theta. So ab sin theta, and we have just seen that ab sin theta is magnitude of a bar cross b bar. So if we want area of the parallelogram whose adjacent sides are represented by vectors a bar and b bar, then this method says find their vector product and take magnitude of their vector product, that gives you area of the parallelogram. Here are some examples. We'll see few examples from which are based on vector product. Find the cross product a bar cross b bar and verify that it is orthogonal, means perpendicular to both a bar and b bar. So first step is to find their vector product a bar cross b bar. A bar cross b bar is given by determinant I, j, k. First row is unit vectors I, j, k. In second row we have to write coefficients of I, j, k from the first vector. Here they are 1, 1, minus 1, that you can see in a bar. And in second row I have written 2, 4, 6. They are coefficients of I, j, k from second vector b bar. We expand this determinant and expansion gives me this vector finally. 10i minus 8j plus 2k. This is value of a bar cross b bar. This is vector a bar cross b bar. Now I want to show that this vector is perpendicular to a bar. This vector is perpendicular to b bar. So what I will do? I will take dot product of these two vectors. या दोन वेक्टरचा मी डॉट प्रोडक्ट घेतो. कोणत्या दोन वेक्टरचा? a bar cross b bar आणि a bar यांचा डॉट प्रोडक्ट घ्यायचं. How we take dot product? By taking product of their corresponding coefficients. Coefficients of I here it is 10. Coefficient of I here is 1. So this 10 into 1, 10. Minus 8 into 1 is minus 8. And this 2 into minus 1 is minus 2. 10 minus 10, 0. So when dot product of two vectors is 0, they are perpendicular to each other. So here we were asked to show that it is perpendicular. It means the vector product a cross b. Vector a cross b is perpendicular to a bar. Prove झालेला आहे. Now in second step I have proved a cross b, vector a cross b is perpendicular to b bar also by taking their dot product. So this is how to find vector product and to show that how that product is perpendicular to a bar as well as b bar. Okay. दुसऱ्या प्रॉब्लेम कडे जातो मी. Find all vectors of magnitude 10 root 3 that are perpendicular to plane of these two vectors. ह्या दोन वेक्टरच्या प्लेनला परपेंडिक्युलर असणारे आणि 10√3 एवढं मॅग्निट्यूड असणारे वेक्टर शोधायचे आपल्याला. ह्या प्लेनला परपेंडिक्युलर असणारा एक पहिला वेक्टर मला माहिती आहे, तो असतो A क्रॉस B. A क्रॉस B is a vector which is perpendicular to both A bar and B bar. So I obtain A bar cross B bar. For finding A bar cross B bar by using Cartesian form, determinant method. In first row we write unit vector ijk. In second row we take unit coefficients of ijk from first vector. Here they are 1 2 1 1 2 1. Coefficients of ijk from second vector -1 3 4. Expand this and we get a vector. This is A bar cross B bar. Now this is a vector, this is just a vector perpendicular to plane of A bar and B bar, but we want vector of magnitude 10√3. Now let us find what is magnitude of this vector. Magnitude of this vector is root of this 5 square plus minus 5 square plus 5 square, and that is 5√3. That is 5√3. But we want vector whose magnitude is 10√3, so we have to double it. So 10i minus 10j plus 10k is the vector of required magnitude and perpendicular to them. If we multiply it by -1, that is minus 10i plus 10j minus 10k, that will be in opposite direction, but it will also be perpendicular. तो सुद्धा perpendicular असेल. म्हणजे ह्या प्रश्नाला दोन उत्तर आहेत. This question has two answers, plus or minus. Third example, if u plus v plus w is equal to 0, then show that u cross v is equal to v cross w is equal to w cross u. So little bit mechanical problem. We just multiply this equation by v bar to both sides and distribute it. So u into v into v and w into v. Now here into means cross product. Cross product of v with itself is 0. So this middle expression becomes 0. So we get u cross v plus w cross v is equal to 0. U cross v plus w cross v is equal to 0. If I shift this w cross v to left side, it will become minus. And if I absorb this minus sign by interchanging v and w, I get the final answer, u cross v is equal to v cross w. Similarly, we can prove other results also. Okay, so let us stop here. These are some applications or examples which are based on vector product. In tomorrow's lecture, we'll continue this with more applications of vector product to geometry. Geometry मधले काही प्रॉब्लेम्स ह्या वेक्टरच्या मेथडने कसे सॉल्व्ह करता येतात हे आपण पुढच्या लेक्चरमध्ये पाहूयात.